say at the beginning. So we have prepared for you a presentation about the other packaging materials. So what can we imagine about the other packaging materials? You can see actually some rubbish over there, but actually it's not rubbish, it's actually made from packaging materials. So we would like to introduce you a few materials and talk about it.
Okay, so we prepared for you a little story, and it was a story about the package. So once upon a time was a magazine, and which was really, really old. And he decided that he wanted to do something good for environment. And he decided to be recycled. And thanks to that, that's how the packages was born. And it was a really long package, and that's why eggs started to live in him. But unfortunately, the eggs were destroyed. And what now? And what we can do with this package? First, it can be a book collector. It was, I know, I'm not sure if it's only in Estonia, but I think in Poland we don't have this kind of things. But it's not too popular because it was really, it was too expensive to produce because people usually use these small bags. It can be used to soundproof. And then now something about the recycling ability. Packages are produced from renewable raw materials and are biodegradable. And something alternatives is a really low carbon dioxide emission. What's more, thanks to that we save natural resources because we use papers, magazines or paperboard, not pure paper. Oh, sorry. And it's reduced air pollution, and what's more, we can recycling this, but we also can compost it and incinerate this. So that's it.
Okay. I will speak a little bit about beverage cans. So those are like soda cans and beer cans and like this kind of stuff. Do you have any idea what's that on the picture?
Okay.
What?
Okay.
Well, that's called bauxite. It's the stone or something like. So they are doing aluminium from that, out of that. So first, the bauxite is mined from a few meters below the ground. So and then it's transported to plants where the clay is washed off and the bauxite passes through the grinder where they make it like little pieces. And then alumina or aluminium oxide is extracted from the bauxite through refining. What is refining? Well, in this process, refining alumina is separated from the bauxite by using hot solution of caustic soda and lime. So the mixture is heated and filtered, and remaining alumina is dried to white powder, and it looks like that. So, and after we have this kind of material, we can start processing it in the metal plant. So the refined alumina is transformed into aluminium. There's three different materials what we need for that. So it's aluminium oxide, electricity, and carbon. So electricity is run between negative cathode and positive anode. So they are both made of carbon. So the anode reacts with oxygen and forms CO2. The result of that process is a liquid aluminium which can be tapped from the cells. So the liquid aluminium is in our case cast into sheet ingots so we can continue to make those cans. And aluminum is very ductile, so foil can be rolled from 60 centimeters to 2 to 6 millimeters, and final foil product can be as thin as 0.006 millimeters. And it won't let light, aroma, or taste in or out. So from those sheets are made beverage cans, and about 75% of those cans are made of aluminum and 25% of those of steel. And in the whole world, the production of all cans is, all beverage cans is about 370 billion cans per year. So it's about 499,500 tons of aluminum. It's quite a lot. So we have a little video how they are making the cans. Is the internet connected here? Oh. Yeah.
Cans are so lightweight that it's hard to believe they're made from a huge roll of aluminum sheeting that weighs almost 10 tons. The sheet is about 5 feet wide and as thin as construction paper. A roll like this is long enough to make 750,000 drink cans. The sheet feeds into a press that punches out round pieces that will be formed into cans. The punch press actually performs 2 operations. It punches at a disc 5.5 inches in diameter, then bends it into a cup. What's left of the sheet gets compacted and sent back to the aluminum factory, where it's recycled into new rolls. The cup goes into a machine called the draw and iron body maker. A tool draws out the aluminum, forming the body of the can. The tool is lubricated so it won't tear the aluminum while stretching it. The lubricant also acts as a coolant because the aluminum heats up as it's being worked. Once the body is formed, a trimmer cleans and straightens the edge. Now the cans move along upside down on the conveyor belt, over to the washer. The washer performs a 6-stage cleaning. The first 2 washes are in hydrofluoric acid at 140 degrees. The last 4 washes are in deionized water, neutral water with no pH, also at 140 degrees. The cans come out of the washer and go under a hot air dryer. They're now shiny because the hydrofluoric acid wash removed a thin surface layer of aluminum. Next, a roller passes over the cans, coating the bottom rims with varnish. This varnish coating allows the cans to slide easily on the conveyor belts and in the vending machines. It shows up as a blue ring under an ultraviolet light. The cans are now ready to be printed. This rotation printing system can apply up to 5 colors, one at a time. The machine then applies a layer of varnish to protect the ink. This is what the print and varnish process looks like in slow motion. And here's the actual speed, 1,800 cans per minute. Next, the cans fly through an oven that instantly hardens the ink and dries the protective varnish. The next machine sprays a water-based varnish on the inside of the cans. This creates a barrier between the drink and the aluminum, so the drink won't end up tasting like metal. It also prevents the aluminum from being eaten away from the inside by the acid in carbonated drinks. Next, the cans go through a machine called the necker, which forms a 2-inch neck on the can. This is done gradually in 11 steps, so as not to puncture the paper-thin aluminum. The next machine, called the flanger, forms a curved-over edge at the top of the can, which will later attach to the pull-tab cover. The cans pass through a sophisticated vision system that photographs the inside of each can. Any can that doesn't meet standards, that has a bump or ink inside, for example, is automatically removed from the production line. They strap the finished cans onto a pallet. From here, they're shipped to the drink company, which fills them and then attaches the pull-tab cover.
Little bit of history. So the first when they started to make the cans, there were a bottom from top and for bottom and top. So they needed a special opener for it. It was called church key. So do you have an idea how it looked like? No, okay. It was like that. So you could make this kind of triangular hole. And they made it two because then you drink from one and the air was flowing or going in from the another, so it was coming out better. So next one was the pull tab. So, but yes, the problem with that, it was like we have heard already in this week. So they like pulled it off and then it went to the ground. So it was like really much. It was bad for the nature, and if we collect it, then the aluminum is really good. We can recycle it really good. The next process or phase was the stay-on tab. So we can open the can, but everything sticks there. So that's good for environment. So recycling scrap aluminum requires only 5% of the energy used to make new aluminum. So the recycling process is like really useful for that kind of material. If we recycle much aluminum, so then we don't need too much of new, like we don't have to start mining it all over. And yeah, the other part is true too. So recycling 1 kilos of aluminum saves up 6 kilos of bauxite, 5 kilos of chemical products, and 14 kilowatts of electricity. So it's quite a lot. So what could we do? Have you got any idea? We in Estonia already are making things better, so we are collecting as much bottles and or like cans we can and recycling them. How is it in your country? Maybe we should apply the same system like we have and like Finland too, so it would be good for our nature.
Okay, so it's my turn now. I would like to introduce you the fight between general plastic bag versus biodegradable bioplastic or ecoplastic. So that's a normal general black plastic, and that's a new biodegradable or bioplastic or ecoplastic, and that's their fight. Who will win, we will see. So basically general information, what is actually, not talking about what is actually plastic, but it is the material which is the most common packaging material, at the same time one of the most difficult to dispose of. So why actually we should use it? Because it is difficult to dispose of. Why? Why? Because it's light, it's strong, and also it's cheap to manufacture. So that's a few reasons why actually we are using it. So a little bit more education about the terminology. So bioplastic, it's actually made from natural materials such as corn starch. Then we've got the biodegradable plastic. It's actually made from traditional petrochemicals, but it's basically breaking down more quickly. And the last one is recycled plastic, made from recycled plastic. So there's some more, I think, interesting statistic and information. We use a lot plastic bags in everyday uses or basis. So over 1 million plastic bags used per minute. So that's a, I think, huge number. Into the market, they've been introduced in 1977, so it's 48 years, I think. 8 years almost. A bit more, money more. And in daily basis, on average, we use plastic bags for 12 minutes, and that's basically the end of the story of the plastic bag. And the production is very, very, very huge. So, do you find this plastic black bag attractive? Plastic bag can be your nightmare for a long time, and so I don't find it very attractive. And basically there's a question why? Why not? Because it takes really long time to break down. Some statistics about 500 years and some evidence you can read about 1,000 years. It's a carbon-based polymers. It's got a long chain molecules that repeat their structure over and over, and it's made from petroleum. A life can be shorter, but nice. That's a motto. So it's a new, attractive bag, biodegradable, bioplastic or recycled plastic. Do you find it attractive?
Yeah.
Oh, yeah? Oh, me as well. So that's definitely, it's attractive. It's more attractive. And there's a more reason why we should use it. More reason. So can help reduce greenhouse gas emissions. Also, less time to break down. Require less energy to produce, and basically they are not toxic, and also in general they are good for the environment. So have you made your mind who is your winner? So again, the fight which I introduced you at the beginning. So I think the winner is a new champion, the Vitaly Klitschko versus some sources, and thank you for your attention.